Bismillahirrahmanirrahim. So, dear students, we'll begin our organometallic series, and today we have the structure, that is the ferrocene. Structure and bonding of organometallic compound ferrocene, the basics about it. Let's begin. So, how we can sum up the basics. So, ferrocene is basically this structure. So, you can start here. This is your ferrocene structure. So it has two forms. This is the eclipsed form, this one, eclipsed, and this is the staggered form. So at the moment we'll just look at this. This is the ring called as cyclopentadienyl ring, and this is another, and there is an iron in between. Okay? So this is the formula how you can represent this ferrocene compound. And cyclic nomenclature is bis. Bis means two. There are two rings. Then this is called eta 5. It means hapticity. Hapticity means, now we have here 5 carbons in each ring. You can see from the structure all these 5 carbons, they are bonded with the iron atom. So hapticity is 5. Okay? There is some sort of coordination. So then this is cyclopentadienyl ring, because each ring is cyclopentadienyl, and iron is present here in the oxidation state of +2. Now, a ferrocene is a sandwich complex. So you can see here, this is basically a sandwich. You see the sandwich, iron in between the two rings. So it's a sandwich complex. It is orange crystals. So when you crystallize this compound, it is orange. And melting point is 174 Kelvin. In solid state, at low temperature, the rings are staggered. So depending on how are these rings oriented. If the temperature is low, then it's staggered. Staggered means, now you can see here, for example, this is one side of this cyclopentadienyl ring, and that side is here in this side. So this is opposite. Likely you can see this is this carbon, and this carbon is here. They're totally some sort of opposite. So this is your staggered configuration. So this configuration occurs at when the temperature is low. The rotational barrier is small. Means if you want to rotate one of the rings, keep one of them fixed. For example, you rotate this ring anti-clockwise, then you will enter into this type of conformation, this type of conformation. You can see now this carbon and this carbon is pointing each other. So they are like mirror planes. You can see this side and this side. So this is now eclipsed. They are facing each other. This is an eclipsed conformation. So this to this transformation is very, very easy. Require low amount of energy. That means these rings are free to rotate. So there is a free rotation. So both these conformations are possible, both staggered as well as eclipsed in case of ferrocene compound. But normally extremely low temperature, that's below 110 Kelvin, the CP rings, they are ordered and eclipsed. So if the temperature is very, very low, it has been observed that the rings are eclipsed. Now cyclopentadienyl rings, they are basically aromatic. Now this is the important point we have to remember. Here also I have shown it aromatic. Means if you apply the rule, the Huckel's rules on each ring, they obey the Huckel's rules, means 4n plus 2 pi. So if you have this 4n plus 2 pi electrons plus 2 pi electrons. So if any system obeys this rule, that has 4n plus 2 pi electrons, and then there is conjugation also, planarity also, the system is called aromatic. So the cyclopentadienyl rings here, they are aromatic. And then one must know that these organometallic compounds where we have cyclopentadienyl group as a ligand, they are called as the metallocenes. So ferrocene belongs to metallocenes, and they have pentahapto ligand, as I mentioned earlier. Now each ring is attached with the metal to all the 5 carbons, so it's called as pentahapto. So the hapticity is 5, that's eta 5. So the oxidation state is +2. Now the number of pi electrons in each ring, that is 6. Remember this. I will just show it here also. This ring is basically like this. Your cyclopentadienyl ring is basically this, and then you have one hydrogen here, and then you have a negative charge here, and then that makes it 6. You can see they are in the conjugation. alternate single and double. So this is your 6 pi electron system. So again I will sum this ferrocene structure. So the hapticity of the ferrocene is 5. Then it has 2 cyclopentadienyl rings, and each cyclopentadienyl ring is aromatic. It obeys Huckel's rule. Then we have a sandwich structure where iron is sandwiched between the two, and then the number of electrons in each ring, pi electrons, is 6. And then as far as the bonding is concerned, the bonding is basically the d orbitals on this metal and these pi orbitals on each carbon. And these two structures, they are flexible, so ferrocene can show the staggered as well as eclipsed conformation. It's just a matter of temperature. Energy barrier is very, very less. So this is all what we have from the ferrocene as far as the basics are concerned.